124.3, the exercises. Start with problem number 1. Locate the roots. Certainly we have many techniques of doing this here. They just want to get a general feel where the root is. And so what I'm going to do over here is just talk about what a cubic polynomial looks like again. Again, looking at it, we know there's a y-intercept at -6. Let's see, 1, 2, 3, 4, 5, 6, somewhere about there. We know it's going to go up, and we know it's going to go down. We know that much about it. All right, so question is locate the roots. Certainly, I certainly know there's a positive root to it. There's 3 roots to the problem, by the way. Let me just erase this over here, and let's talk about things we've done in the past. All right, so we could get upper bound, lower bound, yada, yada, yada. Let's talk about Descartes' rule of signs, though. So what do we got over here? We got the coefficients would be plus, minus. So there's one sign change. So s equals 1. And remember, we had s minus p must be a non-negative even integer. All right? So if s is 1, p would have to be 1. So p is 1. So there's one positive root. All right? So, okay, locate the roots. What are we going to do next? We're going to rotate. And let me get my eraser out. There's one positive root. Let's rotate, see what happens. F of minus x. So to rotate by the y-axis, we're going to make the negative roots to be positive roots. And let's see what happens here. What do you get? You get minus x cubed plus 4x squared minus 6. All right? So what do you get? Let's put the signs down. Minus, plus, minus. So there's a change here, and it's a change here. So s equals 2. Remember, s minus p must be a non-negative even integer. So 2 minus p. So p could be 0, or p could be 1. I'm sorry, p could be 2. All right, so what we're going to do now is, look for it. We're going to start looking for roots. So one positive root, there could be 0 or 2 negative roots. All right? Again, we have many ways of doing this over here, but what I'd like to do is just, talk about sign analysis. And the way to do that is just kind of look at a number line. Start with 0. Start with 1. Right? Go to 2. And what do I know at 0? I know it's negative there. Right? Now, what do I know at 1? It's fairly easy to do, by the way. What do I mean by looking at this over here? It's going to be negative. All right? Now, I'm not saying that how big of a negative number. I just know it's negative. So all I'm worried about. Right? Now, if I go to 2, right? Remember, we're looking for where the root is. I know there's one positive root. If I go to 2, what would I get? 8 plus, oh, gee, that's definitely positive. So what do I now know? I know there's one positive root. It has to be a curve between 1 and 2. So the one positive root occurs on the interval between 1 and 2. So the root, whatever it is, the root x has to be on that interval between 1 and 2. All right? Again, we're using the intermediate value theorem. Now let's talk about the other one. And the other one's going to be those negative roots if they're there. All right? So let's talk about that. And what I want to do is I want to erase some of the problems I have over here. Get my eraser out. I'm also going to erase this and show you where that's written. So let's just talk about the things we discussed so far. So there's a root on the interval between 1 and 2. We mentioned that before. I mentioned that there was one positive root. We've already found that. And I mentioned the negative root could be 2 or 0. There could be 2 of them or 0 of them. All right? So, kind of looking at it. And what do I notice about it? Well, let's take a look at it. Let's go below the 0 and let's see what happens. Well, at 0, it's definitely negative. How about at -1? And we'll get a feel for it. All right, again, we're looking at the function now. So what would you get? You get -1 plus 4, and then -6, still negative. -2, again, just getting a feel for it. And what do you get there? Well, let's take a look at that. Minus 2 would give you what? That would give you minus 8, minus 14, and then what do you get? Let me write that down for you, f of minus 2. You get minus 8, you get plus 16, minus 6. Well, that's definitely positive. All right, so what do I know about this over here? It's over here now. So what do I know? I know there's a root now in between those two. All right, now the bottom line, there's got to be another one. So let's put that down. Let's do f of minus 3. We'll look at the picture later, by the way. What's f of minus 3? Well, it's minus 27. And then you're going to get plus 36 minus 6. All right? It's still positive. All right? Let's do f of minus 4. What's f of minus 4? Well, plug it in. You get minus 64. And you're going to get plus 64. And then you get minus 6. We're negative now. So at minus 4, we're negative. So I know there's a negative root. So a root between, let's see, between minus 2 and minus 1. And there's another root between minus 4 and minus 3. All right, let's just cut to the chase. Let's see if we got those written down for you. So between minus 4 and minus 3, and between minus 2, whoops, and minus 1. All right, let's do the picture. Again, between minus 4 and minus 3, we're just getting a feel for it. A root between minus 2 and minus 1, we got that. And the other root, remember what we said? We said there's another root between 1 and 2, and I'm seeing that as well. All right? We're just locating intervals now. That's all we're doing, locating intervals. Can we solve that? Of course we can, but now we're just getting a feel for where the roots are. That's all we're doing. Thank you.